Let's solve part B now. So what do we have here? Which type of worker will the firm hire at the beginning of the first year if the firm exists for 2 years and the firm has the option to costlessly replace a worker by another worker after 1 year? Okay, so now we have to think about 2 periods. And again, since we're dealing with a company, we're thinking about expected profits for these 2 periods. So we have to solve it for the proven worker and for the risky worker. Now, what would be the expected profits for 2 periods of a proven worker? Well, let's see. The expected profits of a proven worker. Well, we would have in expectation 50,000 euros in revenues with a probability of 1. So for sure, meaning that we would have 50,000 multiplied by 1. And we know that we have to incur the cost of 40,000 euros per period. So minus 40K. But because we're having 2 periods, we have to multiply that by 2 because this would happen again in the following period. So times 2, meaning that as a result, we would have in expectation 10,000 euros times 2, which would be equal to 20,000. So 20,000 euros would be in expectation for the proven worker for 2 periods. With the same logic, we do it for the risky worker. What would be the expected profit of a risky worker if we hire him for 2 periods? Now, with the risky worker, we have to keep in mind the probabilities. We know that with the probability of 0.3, he can generate us 70,000 euros, meaning that in expectation for the first period, we might have 0.3 multiplied with a revenue of 70,000 euros. So 70,000 euros. We have to incur the cost of hiring that worker, which is 40,000. So minus 40,000 euros. And this can happen for 2 periods. Like if the worker happens to be good with the probability of 0.3, he can be good for the first period and for the second period. So we have to multiply this result by 2. So times 2. Now we go to the other case. What if he's not good? What if he generates us only 40,000 euros? Well, with the remaining probability of 0.7, what's going to happen? The worker can generate us only 40,000 euros. So 40,000 euros. And we have to pay for that 40,000 euros to hire him. So we pay the 40,000 euros. But now we have the option to replace him. And because we can replace him, we would go for the proven worker, because the proven worker can generate us for sure 50,000 euros, which is better than the 40,000 of the risky worker, meaning it's wiser to change the worker. So we would go for the proven worker in the next period, if it happens that he is not good. So plus 50,000 euros that we would get from the proven worker, but we also have to pay the proven worker 40,000 euros, so minus 40,000 over here as well. And now it's just a matter of math to calculate. It's just a matter of math to calculate. Let's see what we would get. So let's write everything over here below. We would have 0.3 times what's here, 70k minus 40k. That's 30,000 euros and times 2. So that's 0.3 times 2 is 0.6 multiplied with 30,000 euros plus what do we have in this bracket over here? 40,000 minus 40,000 cancel out. 50k minus 40k is just 10,000, so 10,000 euros over here, multiplied with 0.7, so plus 0.7 times 10,000 euros. As a result, we would have 25,000 euros in expectations. So what can we see? If we do hire the risky worker for 2 periods in expectation, we can have more money. And the reason is that we do have a probability that that worker would be good and generate us 70,000 euros. So it's worth to take the risk and hire the worker, meaning that if we want to hire them for 2 periods, then we will go for the risky worker because he generates more than the 20,000 of the proven worker. So risky worker it is. Hope this makes sense. Next video we go to part C.